everyone, and welcome back to my online teaching platform. Still on application of differentiation in relation to tangent and normal to a given curve. We have our ninth question here, which says if y is equal to x squared minus 3x plus 5, find the coordinate of the point on the curve at which the tangent makes an angle 135 degrees with the positive x-axis. So we are to find the point where the tangent touches the curve and it makes an angle of 135 degrees with the positive x-axis. All right. So let us consider our xy plane. All right. So we have our positive x-axis here, and we have here to be the negative, and here to be the positive y-axis, and here is negative y part of the y-axis. Now we have a condition here which is the tangent makes an angle of 135 degrees with the positive x-axis. So this is what we are going to do. So from here you get your 135. Okay, so your 135 will be somewhere here. Okay, so this becomes our tangent. Okay, so we have 135 degrees over here. Okay, now let us get our curve. So our curve will be in the form of, let me draw my curve. All right, so my curve, which is y, is here. Okay, so let me indicate where the tangent touches the curve. So I have it here. All right, so we are to determine the coordinate of the point where the tangent touches the curve, and it makes an angle of 135 degrees with the x-axis. All right, so from here, from your right, you move to your left, and you get an angle of what, 135 degrees with the positive x-axis. All right, so it means we need to find the slope of this particular line. We need to get the slope of this particular line. All right, now you could see that when you have a line in this form, the slope will always be negative. When you have a line that takes a form of the demand curve, it's going to give you a negative slope, all right, or a negative gradient. Let us get it from this side, right? So we have 135 over here as the angle that the tangent makes with the positive x-axis. All right. So we are left with theta over here. We are left with this particular theta. Okay. Okay. Now, if you want to determine the slope, you just take tan of the angle that the uh, the tangent makes with the positive x-axis, which is tan 135 degrees. So that's how we go about it. So it's going to be tan 135 degrees. Then you get a slope of the given tangent. All right. Now you could see that when you take so gradient of the tangent is equal to tan 135 what degrees. All right. Tan 135 degrees, which is the same as tan 180 degrees minus 45 degrees. Right, so this is what we are going to do. So because when you subtract 45 from 180, you still get 135 degrees, which is the same as negative tan 45 degrees. All right. Now, anytime you have, let us get it from this angle. Let us assume that you have your xy plane, or let us use this value. If you have a triangle in this form, and you want to find the slope of line AB, and you have another triangle in this form, a right angle triangle, and you want to find the slope of line QR, let us look at how best we can determine the slope. Our focus is on the sign, whether we are going to get a negative slope or positive slope, right? So I can put a C here, okay, and here too I can put T over here. So we want to know the slope of this, so M1 and that of M2. All right. So the slope of this part, the M1 will be, you have to find change in what? Y. So that will be AC over CB. All right. AC over CB. All right. If you have this thing, if you have this diagram on the XY plane, let us assume you have the XY plane over here. If you have it on the XY plane, look at it carefully. Suppose you have it on the XY plane. Let's say you have your first X value to be, let's say, 3. That means the next X value will be less than the 3. So maybe here is 1. Okay, 1. So let us assume this is your X1. So you trace it to the line that you want to find its gradient. To the line is AB. Then you trace it back to the y-axis. So this becomes our y1. So x1 goes with y1. So let us assume that the y1 is also is 5. Okay. Now let's go back to our x2, which is a 3. So from the x3, sorry, from the x2, we trace it to the line AB. So where it made the line AB, we trace it to the y-axis. So this is our y2. So let us assume that our y2 is 3. Okay. So this is our y2. So you could say the change will be 3 minus 5. That is y2 minus y1 divided by x2 minus x1, which is 3 minus what? 1. And this will give us a result of negative 2 over 2. We are going to get a result to be negative 1. Okay. Let us look at the second one, our M2. So when it comes to the M2, the gradient will be RT over TQ. Okay. So let us suppose you have your XY plane here. Okay. If you have your XY plane over here, let's look at it carefully. If here is my X1, let us say I have 1 over here. And here is my X2. So I'll treat this one here. I have here to be 3. So I'll trace my X1 to where the line is, line QR is. I'll find the gradient of line QR. So this is my X1. Then where it made the line QR, I'll trace it back to the Y-axis to get my Y value. That is the corresponding X1 value. So that becomes my Y1 value. So let us assume here is also 3. So this is my X2. Let me trace this one to where the line is. So line QR. Then I'll trace it to the Y-axis. That will give you my y2. So let's say here is also 5. Let us find the gradient of this particular line, which is like line QR. We are going to get y2 minus y1. Our y2 is 5, and our y1 is 3 from this one, divided by our x2, which is 3, minus our x1, 1. Right, and this will give us a result of 2 divided by 2, which is positive 1. So you could see that anytime you have a diagram, or you have a line which takes the form of the demand slope, you must get a negative gradient. When you have it in this form, you must get a positive, sorry, negative. And you have it as the supply curve, you must get a positive gradient. So when you have it in this form, you get a positive gradient. When you have it in this form, you must get a negative gradient. All right. So let us find the gradient of the, let's go back to what we're doing. So it means the gradient of, because you have your tangent in this form, okay, and you have your angle from, sorry, because this is your tangent, and you have your angle from here to be 135 degrees. Are you getting it? So you can equally use the angle tan of the angle to find the gradient. Okay. So here is our change in y, and here's our change in what? X. And we know tan theta to be opposite over adjacent. This is the same as the gradient. So we have tan, we are going to use the 135 degrees. It's the same as tan 180 minus 45 degrees. Right. So this will give us negative tan 45 degrees. Okay. Because we know that anytime you find tan 135 degrees, you get a negative result. That will be in the second quadrant. So we are going to get -1 as the slope of the tangent to the curve. And we know that at the point where the tangent meets the curve, they have equal gradients. So our dy dx, which is the gradient function of the curve, must be equal to the gradient of the tangent at where they meet. Okay, so equal to -1. So let's just find our dy dx. So we are going to get 2x minus 3, that is the dy dx, equal to -1. Then we have 2x is equal to -1 plus 3. This will give us 2x equal to +2. So we divide through by the coefficient of x, and that will give us 2x divided by 2 equal to 2 also divided by 2. Then we have x to be equal to 1. All right. So this is the x coordinate of the point where the tangent touches the curve. So we have to find its corresponding y value. So when x is equal to 1, then you find the value of y. We have y to be equal to x squared minus 3x plus 5. So y is equal to 1 squared minus 3 multiplying 1 plus 5. Okay, so we have y to be equal to 1 minus 3 plus 5, and y is equal to +3. All right. So the point A where the tangent touches the curve and the tangent makes an angle of 135 degrees with a positive x-axis becomes a point with x coordinate of 1 and y coordinate of what? 3. All right.